So I asked him to come down and give a talk because he's a physicist like I am, but we both enjoy putting presentations together on different subjects and the like. And so Scott's going to be talking about forensic physics.
Well, thank you so much for the free lunch and the chance to meet you guys. I really admire what you do. I talked to John, I guess, at the beginning of the chat. And I really do think this is a wonderful social group. I heard there were some policemen, retired policemen in the group, so I'll make it clear at the beginning I'm not an expert. Most of the things that I give talks about are things that I'm just interested in and trying to learn more, and every time I give a talk I always learn a few new things. And so this is just a little introduction slide here. I'll tell you this, I took, you'll see it later on, but one of the things that encouraged me to learn about or even first hear about forensic physics was I took a class over in Reno. They had a National American Association of Physics Teachers meeting in Reno. And I took a afternoon workshop with Ernesto Martinez, an Argentine physicist. And it was very interesting. I'm going to show you some of the stuff he presented to us because he served as an expert witness in Argentina during the era of those desaparecidos, when they were assassinating people in Argentina. And his family actually ultimately got threatened because he was serving as an expert witness in some legal proceedings. So anyway, that's how I first got interested in this. And my interests are very broad. I taught a lot of astronomy too, but my background is physics. So anyway, that's just a little introduction slide. You remember the story, remember old Perry Mason? That was when we first got our first TV set in 1953. And Perry Mason, I think, was one of the early shows that I saw. There was Crusader Rabbit and some of these other things. That was on the old TV. When you turned it off, it would go down to a little dot of light in the middle. And later, Jack Klugman as Quincy and Bones, and Angela Lansbury as Murder, She Wrote. And of course, one of our favorites, Peter Sellers, Inspector Clouseau. I love Peter Sellers. And it's interesting, still by way of an introduction, I guess that's not quite aligned, right? Let's see, a little bit, it doesn't matter too much, but I'm going to include a few things in here in my talk that wouldn't necessarily be used in a legal courtroom, so I'm defining forensic physics a little broadly. Because, like I say, the court of public opinion matters too. Scientific issues, but it's really trying to deconstruct things that have happened. What evidence do you have? What hard evidence do you have that might help you to understand what really happened? It could be a murder, it could be a kidnapping, it could be whatever. And so the interesting thing is, for a long time, they believed that Napoleon was murdered by arsenic poisoning. And apparently, like so many things, that's another thing that's involved in the sciences is scientific uncertainty. And so I don't think anybody knows for sure that he wasn't, but they have samples of his hair and found high levels of arsenic in his hair, samples of his hair. It turns out that in the 19th century, they were using powdered wigs that were made out of goat hair. And so they would powder these wigs to make them smell better so you wouldn't smell like a goat. Now I'm just wondering, I'm not inspired by anybody here, but I'm just wondering if that's where the word old goat comes from. But so they would put this powder on the wigs, and it had arsenic in it, sort of incidentally. But they also, I'll get away so we don't get feedback there. What's happening? I'm not sure. There's a time lag. Boy, that's a pretty long time lag. Okay, maybe we turn that volume down. Oh, no problem. Except my old brain is having a hard time processing exactly, that's what I said, right? Good line. Anyway, they were using it for dyes. Arsenic makes a nice green dye, and so there were people dying from the excessive use of arsenic. I think personally, this is a little speculation on my part, but this is in the 19th century is when we were discovering the periodic chart of the elements. You may remember that in your high school classes. We were discovering all these elements and trying to play with them. It was something new, got us kind of the newest cool thing. In fact, we did that again in the beginning of the 20th century. We started using, when we discovered radioactivity, they started making radioactive suppositories, radioactive toothpaste. I mean, we know now you shouldn't use those things, right? But so maybe it was kind of like that with chemical elements earlier on. And Newton is pretty strongly believed to have suffered from mental problems. I don't know any psychology to speak of, but because of mercury poisoning. He worked with mercury a lot. You may not know that Newton worked with alchemy, which was an attempt to convert lead, a base metal, into valuable gold. Right? If you could find the philosopher's stone or something and transform lead into gold, you guys would all be going home looking in your tackle boxes and for fishing and try to turn that stuff into gold. So he worked with that, but he also used it in his physics experiments. He dropped a glass sphere full of mercury from the top of St. Paul's Church and things like that. So he probably did suffer mental issues for about 6 years. He was very delusional and wrote crazy letters to nearby to friends and such. But it was just through his own work on that. One of the first stories that before I met Ernesto Martinez, I hope Art comes back because I don't want to feel bad about his speaker there. I got $50, a grand total of $50 for being a forensic expert once when I was teaching at Sacramento City College. And it was an insurance company called me. And it turned out that it was two boys that had been riding their bicycles along a country road somewhere near Yuba City. And a big truck went by, and one of the boys fell under the wheels of the big rig and was killed. So then they call me, I think 7 or 8 years later, when the surviving brother reaches the age of majority, I guess that's what they call it, he's 21, because then he sued again. There were presumably legal proceedings earlier after the first boy was killed. His brother was killed, and then when he reached the age of adulthood, he was able to sue again. And that's when the insurance company called me, and I was being just kind of a greenhorn. I sort of thought out loud a little too much. And I was thinking of if I could devise an experiment to measure the aerodynamic forces around a passing truck. And to see, and also Horace and I have bicycled through Europe together before. So we're aware of the aerodynamic forces when that sort of shock wave at the bow or bow wave at the front of a truck is kind of a high pressure zone of air. It'll actually blow you a little bit away from the roadway. And then when the truck is alongside of you, because of the Bernoulli effect that explains the lift on an airplane wing, the force would be in the opposite direction. So I could imagine that you might get this kind of a thing on your bike and then this, and it would exaggerate it, right? You'd sort of overcorrect. And I was thinking of how I would devise an experiment along the way. But I think as soon as the insurance person heard this, and as I recall, it was an insurance person, this is a long time ago, whoops, did I do that?
Yes, there's a button.
There's a button there. Hello? Hello?
Tell it turns red.
Okay, it's red again, sorry. I'm not hearing that for some reason.
Battery may be going down.
Okay, I can talk loudly for a little
we hear
while. Anyway, so.
Testing 1, 2.
Is it not working?
The juice.
That's okay. Not a juice. That's my middle name. You guys can hear me reasonably well. I'll try to project as best I can, although I know I don't nearly as well now that I'm getting older. So I think I'm guessing, I don't really know, but they must have settled out of court because the person that was interrogating me sort of asked me questions, I think realized that, maybe there is a case to be made that the liability belongs in the truck company or something like that. So that's my best guess. But that was my first experience, personal experience. And again, then I re-encountered this topic after I talked to Ernesto Martinez. He was a very interesting guy. He had some good stories. Well, one of the first things you could do, and my colleague, Ann Hanks at City College actually did this multiple times, but was to analyze skid marks in trial proceedings, because skid marks give you they're a record of a historical event, a car that locked up its wheels. Oh, Jesus. I didn't realize there are bags here.
Yes.
I'm a wanderer. I'm going to put these over here. Yikes. Okay. Anyway, I just all thumbs and feet and everything. So anyway, she analyzed skid marks, and you can tell, if a car may be turning and leaving skid marks, or decelerating or accelerating and leaving, skid marks on the pavement. It turns out that you can estimate the speed of the car using the skid marks. If you want to get a really good estimate, you need to know the quality of the tires, if they were bald or not, because bald tires are different than tires with tread, but there isn't as much difference as you might think between expensive tires and cheap tires, unless they were the old recap tires they used to do in the old days. But if the roadway is dry or if it's wet, that makes a big difference too. But anyway, this equation that I've got on the bottom is just to give you an idea that how you would calculate the velocity based on the length of the skid mark. So basically, if the skid mark is long, a big number, that means the speed is a big number, just for kind of thinking about it sort of loosely. Anyway, now what happened here? Okay, I'll just advance it this way. And so they calculated 90 miles an hour. This was along the M1 that I rode one time. I think it was the summer that I met Horace. You got batteries in there again? Okay.
So, test it.
Hello? Sorry about that. Okay, let me get a drink of water here. This is kind of a Murphy's Law kind of a deal, right? Anyway, before I met Horace, he and I rode a lot in Europe together up the Rhone River and so on. He was leading a group of young people. I rode my bicycle into London on the M1, and this is the same highway where this famous incident with the Jaguar was. So he was really flying down the road. And this is the thing that one of the cases that Ernesto Martinez talked to me about. There was I don't remember the year, but it turned out that Argentina's best Olympic hope cyclist was out training on a country road in Argentina, and he was drafting behind a big rig truck. There was a small pickup coming toward them in the other lane, and I don't remember if they knew or if he ever said that the driver of the little pickup was either drunk or falling asleep. But the problem was that the pickup veered into the lane of the big rig. The big rig was unaware of the cyclist behind him. So he drifted over on the shoulder of the road to avoid colliding with the little pickup, thereby exposing the cyclist to the pickup, and the cyclist was hit and killed by the pickup. So how did Ernesto get involved with the subsequent court case? Well, they found scratch marks on the side of the pickup. Now this is just an image I found online, and I don't know what the scratch marks were exactly, but this will give you the idea. You could get scratch marks. There are other possibilities, but this is one type of possibility. Probably either the bottom one, that kind of a check mark looking thing, or the other three little scrape marks. It turns out those depend on the relative velocity of the two trucks. If there was really high velocity, the curves, those straight lines would be more flat. Like if the pickup truck was going 50 miles an hour and the big rig was going 40 miles an hour, then their relative speed would be 90, right? They would be 50 going one way and 40 going the other way, so it would be a 90 mile an hour relative speed. So this was a way of corroborating the testimony of the two. If one of them lied and he was really going 100 and he said, I'm going 40, they'd be able to see that. So they used an analysis of the scratch marks as entering that into the testimony in the court case. And it's actually like this. You can do this with a beer coaster. It's a shape in calculus, they call it cycloid. They're pretty interesting to geeks like Horace and I, who study physics and that sort of thing. But it really is And there's an equation there. So V little with a little t is the speed, the velocity of the little truck, and the V with the big T underneath, you see there, is I use that for the big truck, its speed. So it's the ratio of those. And then the 2 pi that's the circumference of a circle. Well, what circle would it be? It would be the circle of the lug nuts on the wheel. The lug nuts on the wheel spinning around of the big rig. Going by, you can kind of imagine it might leave scratch marks depending on exactly how the collision goes, how parallel were the two trucks at the moment they were passing one another. So anyways, those spiky, like Ben-Hur, remember that movie, Ben-Hur, where they had the big things coming out of there? But it's actually a slightly different cycloid because the lug nuts aren't down at the road level, right? They're elevated somewhat. So anyway, that's one example of forensic physics. Probably the first forensic physics case was by Archimedes when Hero, whose nickname was the Tyrant. It seems like kind of a cool nickname, right? He was challenged, Archimedes was challenged by Hero to determine whether or not he had been cheated. He gave a quantity of gold to a goldsmith in Syracuse, which interestingly, Horace and I visited there together too, in Sicily. We've done a lot together. We've been together around the world in many different spots. But the idea was that he gave the king, I don't know how much, let's say Hero gave the goldsmith, let's say, I don't know, a pound of gold. He gets back later a crown that's a pound and it looks like it's gold. But he starts wondering, is it really all gold? Is all of my gold in that crown or not? And so what Archimedes discovered was his law of buoyancy. And he could measure the density of the crown, and he found out it was less dense than gold. So something else was in there besides gold. What do you think would be in there? Do you have any idea?
Lead?
Not lead, but that would be a good guess because lead is about half as dense as gold, as dense as it is. Silver. Probably silver, maybe copper. That's kind of like 18, I didn't know for sure what 18 karat gold was, but I'll show you here in a second. And so I do not, so the goldsmith, Archimedes definitely proved that the goldsmith had cheated Hero. I don't have any idea, and I haven't been able to find out what happened to the goldsmith, but I can't imagine it was good. Archimedes discovered this in that he was taking a bath, according to the story. And we figured out that you could measure the volume of a complex shape simply by submerging it, right? If you had a 2-cup measuring cup in your kitchen and you filled it right to the 2-cup, well, let's say to the 1.5 cup mark, and then you take this odd shaped something or other and you put it in the water so that it's totally submerged, what would that be? Like, I'm trying to think of something that would be really good to put in water to be really...
Necklace.
A necklace, there you go. Okay, so you put it in some kind of a necklace into the water. So it's totally submerged. The water level on the side of the measuring cup is going to go up a little bit, right? It goes up exactly equal to the volume of the material that the necklace is made out of. So anyway, that's the gist of it. And then Archimedes was so excited, and Horace and I, we get this too. Whenever we do a physics problem and we get a right answer for it, we get pretty excited. We didn't do this. What Archimedes did, you probably remember, anybody know what he did? He yelled "Eureka" running naked through the streets of Syracuse. So yeah, Horace and I've never gotten that excited about the solution of the physics problem. Thank you. It's an image you can't erase, is it? So anyway, 18 karat gold, just for the heck of it, is 75% gold. And they put these other elements in to make it harder, among other things, and it's 16% silver and 9% copper. But it's 20% less dense than pure gold, so it'd be easy to measure. That's a pretty big effect. Then there are assassinations, right? We've had 4 sitting presidents who have been shot and killed in office. And the first one was Abraham Lincoln by John Wilkes Booth. And there was no question about who did it. It was found out right away. But it's interesting background information to think about how different was the assassination, whether it was Garfield and McKinley, and then finally John Kennedy was assassinated. And there were some big technical changes between those two. Apparently, I didn't know this, but Lincoln survived for about 12 hours after he was shot. Kennedy was killed instantly. Part of the reason for that is that the bullet that from the Derringer that killed Abraham Lincoln was a much lower muzzle velocity, different shape. I guess it was a ball. I don't know for sure. But apparently, from around the time of the American Civil War until somewhere around maybe the end of World War I, the muzzle velocity of guns went way up. I guess I don't know much about that, but it was later on, decades later, that such high-powered, high-velocity rounds went in, and so. And they refer to tool marks, like if somebody broke into your house and the crowbar or a screwdriver to break in, it'll leave marks on the windowsill or the door jamb or something like that. Those are called tool marks. They actually use the term tool mark also for the marks that are left, scratch marks that are left on a bullet from the riflings of the gun. These are all called tool marks that can be entered into evidence too in a court proceeding that can match a bullet to a gun or just like it's like it would be like a boot print in a garden or a crowbar in the door jamb. And so this one here, I don't want to dwell on it, but for the Kennedy assassination, there was a rumor that there was a second shooter. What happened when President Kennedy was shot from behind was his head pitched forward just a little bit, but then his head pitched backwards a lot, even though the shooter was from behind him. And very near here at UC Berkeley, Louis Alvarez, his son is Walter. Louis Alvarez won a Nobel Prize in physics, and he was the one that was the physicist that analyzed the Zapruder film of the Kennedy assassination and explained why the head would be thrown backwards. And it's rather gruesome, but there's an explosive event that happens out in the forehead that throws the rest of the head backwards. And he was using the back of his head as the reference point. And if you have questions about any of these things, if I'm able to answer them, I'll be glad to do that even during the rest of the talk, or if you want to wait until the end, that would be okay too. The other thing is, and we're going to hear more about the Alvarezes, Walter and Louis Alvarez, because they did another bit of fantastic sleuthing besides the Kennedy assassination. This one you may have I'm expecting many of you to be skeptical about, but eyewitness testimonies are very questionable. This is something I've learned about and found very interesting. But when you see that square that's got the B on it, it really looks lighter to you, doesn't it, than the square that's labeled A? But that's because your eye makes judgments about what you're seeing. It could be incorrect judgments. It looks like the way this graphic is done that square B is in the shadow of the cylinder. And I'll go back and forth a couple times, but they are exactly the same color. Now, to convince you of that, before I gave this talk, I turned my computer around. I tried to look at it with one eye and different to make sure there wasn't some kind of trickery involved. But they are the same shade. It's really hard to believe, isn't it? Raise your hand if you're finding it hard to believe that those are the same shade.
I still see different shades.
You do? Okay. I'm sorry. I meant to say raise your hands if you believe they're different shades. Do most of you see them do most of you think that A really is darker than B?
Yes.
Yeah, it isn't. So this is one of the things. I'll go back and forth. And I'll send this to Horace if you want. If you wanted to look at it at home on your own computer or something, rather than me just saying, yeah, it is, that's not very acceptable to convince yourself, but it's kind of interesting and cool, right? It's hard to believe, but whoops, there we go. If you hold a finger up on the bridge there just to convince yourself, they really, you can at least see, maybe you would grant me that at least maybe there's a chance that I'm telling you the truth. You guys are, okay.
Come a little closer.
Anyway, and speaking of eyewitness testimony, this is a rather abstract rendering of Horace and me 50 years ago. And I wanted to surprise Horace with this one. But do you have any idea what this refers to? Whoa, yeah. Reasonable guess, but not true. Horace and I went down to Los Angeles when we were in graduate school to do research on lead in the air. Back in those days, they put lead in gasoline, and there's particulate matter that people were breathing. And it was Tom Cahill was one of the professors at UC Davis. And so we went down there, and Horace and I were going to stay with a friend in Pasadena. I think it was Pasadena. Yes. And her parents. And we stopped at a payphone to call, because we were both kind of country bumpkins, you know, from up around Davis. And we're trying to find out how do you get to Pasadena. But this is before cell phones and all this kind of stuff. And so we stopped, and we were going to a payphone booth. And I said, one of us said, I don't remember which one, golly, look at that, you know, up in the sky. And we saw something very strange to us. We saw this kind of a pastel light in the sky. It was just
it was white.
yeah, part of my point. It was right after dusk, I believe, according to my memory. It was almost stationary, kind of slowly moving. And I don't recall either of us suggesting it might have been an airplane or something, but we looked at it, and then it became two pastel blobs. No sound at all. We watched this for, I don't know, again, there's a point I'm going to make to this in a minute, because human memory is such that we remember the gist. Humans, we tend to remember the gist of an event, the general idea of it, lo essential, without remembering the details. So we have a framework, and why do we do that? Because it's much more efficient to use of human memory is to remember the core, sort of the framework of an event. But we forget all the details, and then in the retelling of it, we add on plausible details, but they're invented details. But then the third stage, this is fairly recent research, we really believe the story we just told. So I'm not really believing this, because I realize that there's certain details, like exactly when was it, which of us noticed the thing first, you know, and all this. Well, the thing that I found the most interesting, and why I decided to mention this to you, other than it involves both Horace and me and being witnesses to something, the papers got a whole lot of reports of UFOs the next day down there, the local papers. And for me, the most interesting thing was right after we saw this, Horace and I tried to compare notes, and I was kind of surprised to find out how much we disagreed on what we had just seen. You know, try to describe it. Does that comport with what you remember?
Yes.
Yes,
it was white.
Yeah. So anyway, we and I just described to you the recent research about remembering the gist of even recent events, and what we thought we had seen was a UFO, you know, a spaceship or something, but we were reluctant to say that. I just read recently that the error rate for police lineups is about 25%. And there's a book by Leonard Mlodinow, and Horace can give you this too, called Subliminal. And it talks about recent research in these things. And there are people and of course you can always find cherry pick anecdotes, right? If you're trying to prove something, you can always cherry pick some anecdotes that support your contention and you choose to not talk about the anecdotes that don't support your contention. But anyway, having put that qualifier in there, that's apparently what the data is, and I've got a reference for that if you're interested in it. And I don't think there's anything else. I've already just described what I just told you there on the screen. You remember the face on Mars? That's a low resolution. You know, when we see shadows in that, it's kind of like when I was a kid, if I'm in low light levels where you can't see colors and you're just operating on rod vision, where you can see shapes but you don't see colors. I could have a plaid shirt hanging over a chair when I was a little boy, and I could maybe make out roughly that there was a shirt hanging there, but I couldn't see the pattern, or if I did see the pattern, it was all in blacks and grays, no color. But if you look at a high resolution picture of the same spot on Mars, it becomes pretty obvious there isn't a face there. You know, I had a guy who cleaned our windows in our house a few years ago, a really nice fellow. We were talking, he found out I taught astronomy. And after he'd been there for a while, he said, "Do you think we really went to the moon?" You know, kind of that sort of a thing. And there are people who will provide evidence, you know, like the flag, how's that flying like that on the moon if there's no atmosphere? How come there are no stars in the sky? That can be easily explained by knowing something about photography and exposure. You know, stars are quite dim compared to the reflected nearby objects. So anyway, you can use photographic analysis. What can you conclude about the picture? Do you have any idea why would the moon look so big? It could be photoshopped and added in later, but I don't believe it was. Would it be possible to take a picture to make the moon look so big compared to this architectural feature? What would you have to do?
Multiple exposure.
Telephoto, have a
Yeah,
ring.
telephoto, that's it. All you gotta do is be a long way off. Then the moon, because the angular size of the moon isn't gonna change, but the angular size of the building will change. This is something I just learned a few weeks ago about our observing our world. We were talking about dark, you know, low light conditions, bright conditions, various shadows, how the eye can be fooled. Oh, and by the way, I didn't ever tell you, but do you know what the thing was in Los Angeles when Horace and I saw that? It was we were not used to being in smoggy air. And the LA basin was terribly smoggy in those days. What we were seeing was through a very thick layer of smog, we were seeing a rocket staging from Vandenberg Air Force Base. So as the rocket, it was so far away that there was no sound involved, no perceptible sound. I'm sorry I didn't say that before. And staging, and because it was so far away, it not only was quiet, it also moved slowly. You know, when something's very far away, even a supersonic jet looks like it's moving slowly. This is another story with Horace and I. He claims that I saved him from a rattlesnake one time.
You did.
No, I don't think so. We're walking down a trail. There is something we don't even need to process, some visual information. We do not need to process it mentally, consciously. It's just, it's our subconscious handles it. And we're walking down a narrow trail with grass maybe up knee high on both sides. And we walk through between these two big boulders, and I put my foot down probably 18 inches away from a rattlesnake. And I only saw about this much of his body. I kept gesturing like this, I just learned that this is pulvinar part of our brain that it does not need to process it. It recognizes that pattern as being distinct from, say, bird's feathers or something else. And I joked with Horace, but I'm kind of half serious. It was a narrow trail, and we were single file. Horace and his wife were behind me. And I don't know if I think it was maybe just the three of us on this hike. And the next thing I knew, I was behind Horace. I think I did one of those crouching tiger, hidden dragon things, you know, where I jumped in the air and went over, but I was some kind of a quick muscular thing where I just almost went into orbit. And so I just thought I'd share that with you too, because I think it's kind of fun. And where are we on time, Worth? Because I want to.
120.
We're still fine? Okay, good. I've cut out a lot of stuff, but I was hoping I could get through these things. Anyway, this is just sort of a list of the tools that you would use in forensic physics. A thermometer. Remember the O.J. Simpson thing? Remember there was a little container of Ben and Jerry's ice cream on the banister. An investigator going to the crime scene, you would think would want to know, was the ice cream melted? Was it fully melted? What was its temperature? Was it room temperature? Because that would lend itself to experimentation, right? You could go buy, hey boss, I gotta go buy a dozen containers of Ben and Jerry's ice cream and sit there and watch it melt and decide, but that would be it. So even just a thermometer or corpse temperature can also be used as an indication of the time, a rough indication of the time of death once the metabolism stops in the body. Distances, we've already talked about that with skid marks and such. Neutron activation analysis is for looking for trace quantities of you've got a very tiny sample of something. You can measure very tiny quantities of that. And this was used not for tiny quantities, but after the Hiroshima bombing, the atomic bomb, the copper plumbing was transformed, some of it, into radioactive nickel. So how much radioactive nickel they found in the plumbing was an indication of the explosive yield of the atomic bomb, which was 3 days after I was born. Looking for genetic, more molecular information, the polymerized chain reaction way of measuring DNA, I guess a pretty small sample, I don't know, but a very tiny sample, can be amplified into a considerable quantity of identifiable DNA. And we've all, we're of that vintage, aren't we? I mean, the DNA molecule was discovered in most of our lifetimes. Just the fact that it even exists, and now the technology is really pretty phenomenal. And and I just found out this last summer that I'm mostly Scottish, so my mother named me well. And sound. Remember the Gene Hackman movie that was down in Union Square? It was about where he was sound. It was sound analysis. I can't remember. Does anybody remember the name of that movie? Gene Hackman. It was where he was analyzing sounds. It was a conversation between two criminal types, some terrible crime, a murder or something like that. And he was trying to pull their voices out of the din of the noise from the crowd. It's really, I love Gene Hackman too, but. Anyway, I'll just kind of go through some of these a little more rapidly. I wanted some things I'd really like to get to. Well, another Nobel Prize winning physics besides Louis Alvarez is Richard Feynman. You may remember that when the Challenger disaster occurred, that he did an experiment right at and I suppose it could have had an element of grandstanding. I don't really know. But it turned out that was the problem. You see this little, where the white arrow is there, that's the O-ring that started the chain reaction of events that destroyed the aircraft, the spacecraft, where the O-ring blew out. And it turned out that before launch, they had unusually cold weather there, and I guess it was Cape Canaveral in those days. And it was a horrible, horrible incident, but that was, he really found out what was the initial clue that would lead you into an understanding of what events transpired. And there were all kinds of, it's a very complex thing, putting such a spacecraft. It takes a lot of people, a lot of different teams working together and trying to find out how can we do this better and avoid this happening again. And then here's a little one on, I like things that are counterintuitive, especially we're getting this in crazy weather now. I just heard from Morris's wife, Lynn, this morning that Big Sur's going to get a foot of rain in this next day. That's hard. I got to believe. Did you miss? Is that a typo or is that really true? But it's so interesting that how would climate change? How would warming of the slow warming of the planet? And it's really kind of almost hard to believe it's an issue because you're talking about 1 degree Celsius over like a century. I mean, we fight over thermostat settings. 1 degree is kind of nothing. It seems like such a small change, but it's so for the whole planet. And what happens is you'll get an idea of how could that lead to such cold weather like happened back east. These are the cities, the warmest January. I have it here, the warmest January. I thought it had the word January in there, but it says. Oh, it is. There it is. I'm sorry, I wasn't paying. Bridgeport, Worcester, New York City, they have their warmest day in January, warmest January in history. And then watch what happened just a couple weeks later. Oh, I was trying to get you to see. I'm sorry, I just forgot I had the graphic. There's Jupiter. The same thing is happening on the Earth. The equator gets most of the heat. The poles are cold, right? So the heat, when you cook a soup, the bottom of the pan is the hot part. It's right above the flame. So the soup sort of churns and boils. That's called convection. It stirs itself, but in kind of a disorganized way, a little, hot stuff, plumes coming up and cooling and sinking. It's sort of stirring itself. Well, if you have a system that's spinning like Jupiter, then that attempt for heat to move from the equator to the poles is stretched out into these horizontal bands where you get easterly winds and westerly winds, like we have our trade winds and such. Jupiter's got like 10 of these bands, but this was a couple weeks later. They go from the warmest January in history to incredible cold in New York City. And how does that happen? Well, the poles have warmed more than the equator. And I remember hearing that when we were in graduate school, that the poles will warm more than the equator, which seems, obviously the equator gets most of the sunlight, but over decades of time, why would the poles warm more than the equator? And there's a couple reasons that I've learned very late in my life. And one is that carbon dioxide is more dominant greenhouse gas over polar regions, but the one that's easier to understand is that you've got white, glacier, ice white ice floating on the sea. If you melt it, it becomes black seawater. Seawater is really good at absorbing sunlight. Snow is really good at reflecting sunlight. So if you take an acre of white and it becomes an acre of black, that's a big change, right? So that kind of feedback mechanism is one of the reasons why the poles have warmed more. So what's that done? The equator has warmed since we went to graduate school, and the poles have warmed. But the poles have warmed more. So the difference is less. Does that make sense? The difference in temperature. The poles are still colder than the equator, but not as much colder as they used to be than the equator. And so what that's done is it's weakened this convection, this churning that generates the trade winds and such.
It's weakened the jet stream.
It's weakened the jet stream that contains that. And so it's kind of like a yarmulke or something that sort of slips off. You know, it gets this loopy behavior. And so this air that they're labeling as very cold is very cold. It's polar air. It's not as cold as it would have been 50 years ago, but it's still way colder than we're accustomed to at these latitudes. I hope that gives you a little bit of a hint of the answer, but Arctic air on the move. And here's a picture of our Earth. I'll just leave that up for a second so you can see it. So we get heat moving from the equator up to the poles, but it doesn't do it in one fell swoop. It does it in these loops. And of course, the advent of the existence of the trade winds and so on was really well known by the European explorers, traveling around the world in early sailing ships 500 years ago, taking advantage of these prevailing winds that are generated all because of the energy of the heat energy at the equator trying to move toward the poles, but it's affected by the swirling, the rotation of the Earth. Well, I learned something else new for preparing for this talk, and it was something I didn't know about before. When I gave my talk 10 years ago on this subject, and that is, one is that the Mona Lisa was painted on wood, on a piece of poplar plank. And it was stolen by an employee at the Louvre. And there's a story that I'll just give you the little thumbnail sketch of it because you can look it up. But there was the idea that when it was stolen by this employee of the Louvre, of a janitor, I guess, I'll put his picture out here, Vincenzo Perugia, it was gone for about 3 years. He tried to take he kept it in his house, evidently. And then he took the Mona Lisa, he took it to the Uffizi Gallery in Florence, Italy, and tried to sell it. And he was arrested, and he spent, I can't remember if it was a year in prison or something, but he was imprisoned. So that part of the story is evidently true. But the question is, there was a fellow, Eduardo Valfierno, an Argentine fellow, swindler, but he may be invented. So when you read it, I don't really know. I've just seen that. The idea was he put Perugia up to the theft, and then while the Louvre was missing the Mona Lisa, he had 6 replicas of the Mona Lisa made, and they had wealthy buyers. Hey, you want to buy the Mona Lisa? This kind of thing. Apparently, according to the story, and this may be just entirely invented, I don't really know, but it's at least a good story, is they were buying what they thought was the real Mona Lisa, every one of them. But you gotta be quiet, because it's stolen material. And so then everybody buys it thinking they've got the Mona Lisa. It would be a good ruse if you could pull it off, right? And then, so the idea was that the Mona Lisa that was returned to the Uffizi was really a forgery. But you could determine, this is kind of a long way around, but you could use forensic physics to determine if that's true or not. Because poplar is carbon material, right? Wood. So you can do carbon-14 dating and say, well, that wood is not 400 years old, right? The time that Da Vinci would have painted it. So you can actually use radioactive dating. That would be good evidence that would tell you whether or not it was plausible that it was, in fact. And you can also do similar kinds of techniques on the pigments that were in the paint. So part of that story is true. Part of it may be invented. I don't really know. I kind of, in a way, want it to be true because it's such a cool story, and it kind of implies that the Louvre has a forgery hanging on its wall that everybody goes to see. Another connection with Horace is when we were at Davis, we had the good pleasure of meeting a wonderful man by the name of John Youngerman. He would be about 100 now if he was still alive. John is the guy whose head is in line with this post back here. Right there, he was a part of this is a group from the Manhattan Project for the building of the atomic bomb that I alluded to earlier that was dropped on Hiroshima. And this is Emilio Segre and Owen Chamberlain. They are both got the Nobel Prize in physics later on. And John actually witnessed the Trinity test in Alamogordo, New Mexico. It's an interesting story. I won't go into it here. But anyway, they were doing all this. In those days, maintaining secrecy was different than it is now in the modern age, with cell phones and the internet and social media and so on. But they were trying to find places like Hanford, Washington, Los Alamos, New Mexico, Kentucky, what's the one? Oak, Tennessee, that's one, thank you, Horace. Oak Ridge, Tennessee, places where the local population was very sparse and maybe not very well educated. It made it easier to maintain secrecy. That's one of the reasons that they chose those places. Well, because of their work, there was from the late 50s through into the 60s, a decade at least, I don't remember the exact years, a lot of atmospheric testing that put a lot of this radioactive 14 up into the atmosphere. And the interesting thing is that reset the global atomic clocks, so to speak. If you find an old spear or something like that that's maybe 10,000 years old, a shaft of an old spear in some archaeological dig, you can use carbon dating to say this thing is, roughly 12,000 years old, maybe plus or minus 500 years or something. But you can't do that with new things. But the interesting thing is, you couldn't use radioactive dating to determine my age, because I would have, well, I guess I won't go into that, but I'm not old enough for that to work. But for babies that were born in 1968 or 1978 or 88 or 1990, whatever, everything was reset, because once that carbon got put up into the atmosphere of nuclear testing, which mostly has decayed almost back down to zero finally after many decades, allows them to go get a shipment of illicit drugs. And they can tell these drugs, unlike regular carbon-14 dating prior to the age of nuclear testing, atmospheric testing, they can say these drugs were produced in 1978, plus or minus, I don't know what it would be, plus or minus a year or two, fairly precisely. And they can also tell where they were made, or at least provide evidence that contributes to knowing where they were made. And so you can discriminate between drugs, cheese, wine made in 73 from 1987. You're actually going to be able to get, that's pretty fine. Normal carbon dating doesn't get the dates down that close. Okay, I'll go through that a little faster because I don't want to use up too much time. There's also another kind of thing, if you think it's cool, you can look it up, thermoluminescence. But if you have anything that was fired pottery, if you have fired pottery that was fired in 1800, or fired pottery that was fired in 1100, or even, I think it goes way back, that you can, when you heat it up, so it's never been fired again. It was fired up to, I forgot what the temperature, I think I have it written down, 500 Celsius or whatever. It glows, it gives off light, and the brighter it is, the older it is. It's a really kind of weird, interesting thing, but it's called thermoluminescence, if you wanted to look that up. But it's a totally different, non-radioactive way of dating things. And in physics, we always like to be able to measure something by more than one technique, because then you get some double checks, and it kind of adds to the credibility of the evidence if you have double checks. So here it is, that the fluoride on the left this is a photograph of when it was being heated up. And the other rock is to show you that it doesn't, it's either not as old or it's a material that doesn't have these so-called electron traps in it. And then another case And they did use the trace element analysis to figure this out, but I don't know if you remember this guy, Alexander Litvinenko, and he was poisoned by the KGB. He was a former KGB agent himself, and he died, I forgot, I think it was like 3 weeks after he was given the dose of polonium, and he was poisoned. Well, here, I got it here, I'll just put all my bullet points out, you can read them. So he was poisoned on November 1st, and he died, it was 3 weeks later, he died 3 weeks after this. And but it was spread all around. Just a tiny, 10 micrograms is a really tiny amount, but it was enough to kill a person. And the data production was easy to determine because the half-life for polonium-210 is 138 days. So they were able to backdate when was the polonium that killed him produced. And then by looking at the trace elements that were found with the polonium, evidently they could figure out where, or a likelihood of where it was likely to have been produced. But there's always uncertainty, right? Whenever you come out with the data, beyond, they have that language beyond a reasonable doubt, don't they? Isn't that part of our legal code? I think this is the last story I wanted to tell you. Okay, Horace? Louis and Walter Alvarez, Louis' son, was a geologist at Berkeley, maybe still is, I don't know. Probably not. It seems like this was quite a long time ago. They were looking at geological evidence for what caused the extinction of the dinosaurs. So they're trying to reconstruct any event or sequence of events that might have led to the extinction of the dinosaurs. And Horace and there was a meteor impact that is well known that happened about 65 million years ago. It was roughly 6 miles, I'll say 5 to 10 miles across, that hit the Earth at some 30,000 miles an hour. And it hit, and then they didn't know where it hit at first, but there was a search to find where it hit. Do you know where it hit?
Cancun.
Yeah, near Cancun. And just joking your head for the hills. Here it shows you, it's off of Progreso, north of Merida in Spain, in Yucatan. And Horace and Lynn, and my wife and I, Linda and I, we got together right over here in the Celestune. It was a great trip, right, Horace? And they found, you see a circular arc of the cenotes, and you see evidence on the sea floor. That is the crater. That's an enormous crater, right? And that is almost certainly, with I would say a high level of scientific uncertainty. There's never zero uncertainty, never. There's always going to be some uncertainty. Having said that, there's a high level of certainty to say that this is really what happened. There's a lot of evidence. And they found this element, iridium, around the world that was at a concentration in this particular geologic level corresponding to sediments from 65 million years ago. That's 30 times higher than normal level so it's a pretty strong signal. And that was the element iridium. And I wanted to put these in addition to the elevated levels of iridium at that level, they found soot around the world. There was evidence of global forest fires because when you hit with that kind of energy, it heats to incandescence, heats to igneous form, to liquefy the rock. And so now you have liquid chunks of rock flying in suborbital flights and landing all around the world, igniting forest fires. So global fires that left soot in this level. And there is another, it's thought that this may have been the nail in the coffin for the dinosaurs. There were other factors. There's one in India called these Deccan traps. And it's a volcanic, natural, internal volcanism of the Earth that was also apparently putting a challenging environment in front of the dinosaurs. But evidently this impact is pretty widely accepted now, is the thing that really sealed the deal for that mass extinction. We've had probably 5 or so real huge mass extinctions. This is my last picture that I couldn't resist putting in. And this is because my wife just found out through genealogy that she's related to a witch. So she gets no respect for me when I go home. I don't want to mess with her, right? If she starts doing any kind of hocus pocus stuff, they're gonna watch out. But Martha Sparks, her relative, was incarcerated with, I meant to ask her before we came today and I forgot to, but she was incarcerated with one of the really famous witches from the Salem witch trials that was put to death. The last thing I'm going to tell you, we old fellows here, is Martha Sparks was not put to death. And the reason she wasn't put to death was because of an old person. And that was her dad. And what had happened was she had, to get into jail, all it took was somebody to accuse you of being a witch. And there were some men that were apparently accused of witches, but I think it was mostly women, but I don't really know. But it didn't take any evidence to put you in there, really, just the testimony of one person. But once you were in, they had some tests to see if you really were a witch. And one of them was, can you read biblical scripture without making a single error by memory, some passage, Lord's Prayer or something like that. And then the other was they would bind you up, and it was a swimming test. They would bind you up and then throw you in a lake or a river and just see if you could swim. If you floated to the surface, it was because you were being rejected by the water, which was seen as, in baptisms, water is used. And so you were being rejected. If you sink, you're not a witch. That's a lose-lose deal, really.
But you go ahead?
Yeah, okay, maybe, yeah. So anyway, so what happened was her dad, during this time she was gone, her husband was off fighting in the American Indian Wars or something like that. And so her father was the man of the house, so to speak, and he and his wife were having to take care of her kids while she was in jail for a little over a year. And so, but then his wife fell into ill health, and so now it was upon him to take care of the kids. And so he thought, I better do whatever I can to get her out of jail to take care of the kids. That story rings true to me. You know, I can imagine that's true. So he wrote a letter to the governor anyway, that's all. But I thought that would be kind of a fun note to end on. So thank you so much for having me.
Thank you, Scott. Are there any questions for Scott? Alva? Mike?
So to test the Mona Lisa, wouldn't you have to take a piece of it out?
Yeah, I can imagine that would be hard to do. And not get into trouble. And I'm not, like I said, I'm not an expert. The thing that's amazing to me is what we can do with our modern technology. Little tiny samples, maybe some academic institution, if it was in France, maybe if they said, maybe there was a bit of spatter paint somewhere. I don't really know the answer. It's a very good question. But I know, like, the Shroud of Turin was one of the other things I was going to talk to you about, and they have tested that, and sometimes you get a mixed story on what happened. Somebody else had a question? Yeah.
Well,
Bart.
Do you know the Mona Lisa in France now is the original?
I looked it up. Of course, we all are fans of Googling these days, right? One of our favorite words. So I did my share of Googling on this, and I don't really know. They would, of course, want all of us to believe that I would think that it's the real thing. The only thing that is apparently very certain about this, is from my reading, is that it was stolen, which I had never heard of before. Have you guys heard that before? How many of you have heard that the Mona Lisa had been stolen over 100 years ago? Yeah, so again, I think that doesn't mean it's true that all of you are raising your hands, but I think, evidently it was stolen, but the rest of it could be just malarkey. What is, somebody else have a question or no? Well, again, thank you so much for coming. It was a real pleasure.
Thank you.